We started coding Django Booster because a programmer and system designer said there has to be a better way. This is a paradox since Django Framework is a very efficient programming framework and Django's main idea is dry. Do not repeat yourself. Why create a tool which automates a coding process for an already very cost-effective programming language? We realized very quickly that a code generator would cut the programming time to fragments of normal development time. But at the same time, we also learned that the code generator actually ensured that the code was standardized, structured, and very easy to maintain. In short, we improved both the development time and code quality in the same process. Software development time equals money spent, and money spent means budgets. So choosing the development environment is crucial to decision-making inside an organization. Ultimately, budgets decides whether a project initiates or not. I can prove this bold statement very easily. Currently, more or less all organizations have an abundance of Excel spreadsheets that handles a wide range of different tasks. We all know that data inside Excel is insecure, cannot be shared, usually completely undocumented, and yet all organizations seem to have Excel involved in more or less all business processes. Why is that? Simple answer. Because you do not need a budget to start an IT project in Excel. You just need an idea and some basic spreadsheet knowledge. The rest of this video will focus on the economy that an organization allocates to a software development and how that affects the result, and ultimately whether an organization will solve the IT challenges at hand or not. We will base the explanation on a graph. The main idea is that each software development tool has a sweet spot somewhere. Excel is great for simple, individual solutions where one employee can solve the job. Initiating an Excel solution is cheap and simple. RAD tools like Microsoft Access or FileMaker are great at solving simple to medium complex solutions where a limited number of users are involved. You do not need programmers to define a RAD solution unless you want to utilize the more advanced features. Initiating a RAD solution is doable, but it will always involve a budget. Traditional tools like C#, Java, Python, Go, or PHP are great at solving complex solutions where many users have to use the system and where data security plays a major role. Initiating a programming project is expensive, and you need to involve specialists very early in the process. The problem is that an organization has to choose the software development tool before the organization can predict how a system will evolve. And if you choose a cheap solution, and over time the demands to the software solution exceeds the base capabilities of the software tool, the project fails. The software project can fail in two ways. Either the software development tool does not have the facilities to solve new demands. This will mean that you have to compromise with the needed software functionality or scratch the solution and start over. We have met the end of functionality point on the graph. Or the software development tool can handle the implementation of the new facilities, but it is not built to reuse code, which will lead to increased development time for each task on the to-do list as the project grows more complex. We have met the regret point on the graph. The software project is only 100% successful if none of the two problems mentioned above occur. If an organization starts a software project based on traditional programming tools and the organization has allocated the budget for the project can also fail due to two reasons. Excel or RAD could initially have lifted the challenge and the project never reaches a complexity where it was necessary to change development environment. In this case, the organization have spent unnecessary money solving a simple problem. The software company or internal programmers and the people defining the project fails in their communication, and the result of the developed software does not solve the actual problem. In this case, the organization wasted both time and money. And yet, the challenge still exists. Organizations need to allocate big budgets for software development where the ambitions are great, but each project represents a financial risk, and the bigger the budget, the bigger the risk. Django Booster solves the issue about minimizing software development time, hence cutting overall software development costs. But choosing Django Booster also means minimizing risks. When using a programming language, you need programmers, and normally doing programming is tedious and time-consuming. Django Booster projects require people with knowledge about the business procedures to define a solution. Initially, you do not need programmers. When the analysts have defined the project, press the Code button and Django Booster creates a functional application. This phase compares to working with RAD development tools both in terms of the knowledge needed to operate the software development tools and the costs and risks involved. The result of pressing the Code button is well-structured source code in the Python Django framework. The result is source code in a traditional programming language, which do not have the limitations that RAD tool code usually has. The source code is extendable to deal with complex security, functionality, and multi-user concurrency issues. Of course, extending the source code requires programmers, but it is doable, and the generated code is easy to understand and well documented. By using Django Booster, we combine the best of both worlds: low initial budgets like in RAD projects, and ability to create projects that are extendable to deal with very complex IT scenarios where you do not risk meeting the regret point. A traditional software project with a traditional programming language has 5 stages: analysis, prototype, programming, test, and production. We know we are generalizing, and the number of stages depends on the development model, but this is a simplified presentation. Django Booster ensures reduced programming time in all phases. The analyst time is not reduced compared to traditional projects. Django Booster can reduce the development time of a software project with normal complexity to half or less, which of course is great. We earned the reduction of development time in the initial part of the development project, which results in much less risk, especially for organizations where available programming hours are a limited resource. All software development projects are different, so predicting time and cost saving is very hard. But in general, the more standardized a software project is, the bigger savings. In a software project where users have search, sort, and update records in a relational database as the main task, Django Booster can reduce development time to 10 to 20% of traditional development time. If the software project consists of advanced calculations, complex workflows, and other non-standard elements, the time reduction is less. We base the 50% reduction prediction mentioned before on an average complex project. Try Django Booster and realize that you and your organization can increase software development ambitions and at the same time lower costs and risks.